Hello friends, welcome to Susan and John MathTube. This is lesson number 6 in Laplace transform. In this lesson, we focus on more problems that had been asked in your past paper questions. Okay, so as always, the most important question, how to use the video lessons effectively. And I'm sure you know the answer, and I hope you are practicing that. So let's start with lesson number 6. So what's the first thing to do? Yeah, spend 1 or 2 minutes and make all the formulae perfect. Yeah, I know you know most of the formulae, but it is better that you read the formulae again and again and again so that you don't struggle with formulae in exam. And in the last video, that is in lesson number 5, we learned a few properties, and I told you normally they ask 2 small questions in Laplace transform, and normally they will be based on these formulae or properties. And property number 1 tells you, if you know the Laplace of any function, you can find the Laplace of the same function multiplied by e power at. What should you do? You should take the original answer and replace s with s minus a. And if you multiply by t power n, you have to differentiate answer again and again and again n number of times, and don't forget this minus 1 to the power n. And the last property we didn't apply, but it is for division. That means if you calculate the Laplace of any function, you can easily attain the Laplace of the same function divided by t, provided you find the value of this improper integral. So shall we start? Anyway, for your advantage, I kept the formulae, or let's say the properties, on this corner. Let's do one simple question first. So please write, find the Laplace of t into e to the power minus 3t into cos 2t. Okay, we have done similar problems in the last lesson also. So tell me, how do you start? Yeah, that's nice. We start with Laplace of cos 2t. Cos means it will start with s by s square plus 4. Okay, now what you do is you write the same thing. Therefore, now we are going to apply one of the properties, because you can apply this property or this property and the order does not matter. Anyway, I am going to write the same thing, and I am going to multiply this with t. And if you multiply by t, what is the condition? Yeah, you have to put minus 1 to the power 1 and differentiate the above function once. Okay, tell me please, should we apply u by v rule or not? Yes, because I can see s in the numerator and denominator. So I can write like this, that is Laplace of t into cos 2t is equal to minus and a big bracket. Minus comes from here. What's the denominator? S square plus 4. So s square plus 4 times 1. S square plus 4 times 1 minus, so denominator and derivative of numerator minus numerator and derivative of denominator, the whole divided by denominator, the whole square. That is Laplace of t into cos 2t will be equal to, let's simplify, minus of s square plus 4 minus 2s square, the whole divided by, that is Laplace of t into cos 2t is equal to minus of, we can combine these two and you will get minus s square plus 4 by s square plus 4 the whole square. And this minus goes inside and we distribute it. So now I can write t into cos 2t. The Laplace transform will be s square minus 4 the whole divided by s square plus 4 the whole square. So once more I'll tell you, they asked us a question, find the Laplace of the product t into e power minus 3t into cos 2t. Since it is a product, the order does not matter. You can write in any order you like. Anyway, we don't have any property. Look at the three properties. We don't have any property involving cos. So that is exactly what I found first. Now you have an option. You can either apply the property for exponential or you can apply the property for t. Anyway, I felt like differentiating, so I multiplied this by t. And if you multiply by t, what are we supposed to do? Yeah, put minus 1 whole power 1 and differentiate once. And that is exactly what I did, and simplified and I got the answer. Now what I do is, I'll write the same thing. So you just told me you know the Laplace of, look at this, you know the Laplace of a function. And now I'm going to multiply this by e power minus 3t. I think you still remember the question. We have to multiply by t as well as e power minus 3t. And what does the property tell you? Yeah, I'll circle that S for you. In the exam, don't circle in your answer paper. So we get s plus 3 the whole square, the whole divided by s plus 3 the whole square plus 4 the whole square. I hope you're okay with that. Now another question, and I'll give a hint for that and you can proceed yourself. So a combination of trigonometry and hyperbolic as a product. Whenever you have this, you convert this hyperbolic into its original format. That is, we know that hyperbolic functions are exponential combinations. So this is e power at minus e power minus at by 2. And the next thing is like what you call, I can see 1 by 2 here. So that goes outside. And now you have to do one more thing, that is you apply linearity property. But before we apply linearity property, let's distribute this cos. So we get 1 by 2 Laplace of e power at cos at minus e power minus at cos at. Now we can apply linearity as I told you before. E power at cos at, be careful with the bracket, minus Laplace of e power at cos at. Okay, now in one corner you can write Laplace of cos at. What is Laplace of cos at? It will start with s by s square plus a square. So if you multiply this, now we are going to apply the first property. We know the Laplace of cos. We know the Laplace of cos, but we want the Laplace of e power at into cos at. So what should you do? You replace s with s minus a. Now that's it. Now I have given enough hint. So you can proceed. Now something very important, because this is a problem which we did not do in lesson number 5. And now I hope you'll be able to handle symbol type questions like this. Yeah, okay. Okay, the question is, find the, please mark it important, find the Laplace of 1 minus e power t the whole divided by t. So I hope you can see that last property, division by t. So what I do is I will write Laplace of 1 minus e power t. What is Laplace of 1 minus e power t? 1 is 1 by s and e power t is 1 by s minus 1. Okay, now what I do is I write the same thing. Once more I'll tell you, if you know the Laplace of the numerator, that is what the property tells you. If you know the Laplace of the numerator, then you can have the Laplace of the whole quotient ft by t by integrating. So look at this. This step guarantees that you know the Laplace of the numerator. So if you divide by t, we apply the last formula, that is integral s to infinity this answer, 1 by s minus 1 by s minus 1 ds. Anyway, if you want you can do it directly, but I will not prefer because this is an improper integral. In the first semester, you learn about improper integrals and there is a technique to deal with improper integrals, and you should always follow the proper method. The question is not whether you will get an answer or not. Sometimes improper integrals will cheat you. If you take your first semester book, there are some problems in which if you don't apply the proper technique, you will never get the answer. But sometimes, of course, you will get the answer. Okay, anyway, we'll continue. That is equal to, now tell me, how do you make improper into proper? Yeah, limit y tends to infinity, integral s to y, 1 by s minus 1 by s minus 1 ds. So I just made the improper integral into a proper integral. Okay, now tell me, what is the derivative of log x? Yeah, it is 1 by x. Okay, so what will be integral 1 by x dx? Yeah, of course, log x plus c. So we are ready to integrate. So we get limit y tends to infinity, log s minus log of s minus 1, what you call within the limits s to y. If you want, you can make it very clear. Look at this. The variable of integration is s. So it is better to write s varies from s to y. Okay. Now one very important question. Wait a minute. Yeah, log. Yeah. Okay, so what is log a by b? I think you remember that property. Isn't it log a minus log b? Exactly, log a minus log b is log a by b. Okay, we will apply that. So we get limit y tends to infinity, log s by s minus 1 within the limits s equal to s to y. Now time to plug in the limits. So we get limit y tends to infinity. Now I want you to plug in the upper limit for s. So it becomes log y by y minus 1. Now you can plug in the lower limit for s. And if you plug in s instead of s, basically nothing happens. Okay. Now this can be split. Limit y tends to infinity, log y by y minus 1 minus limit y tends to, in the exam you can skip this step. I just want to show you this step so there will be clarity. Look at this. Here the limit is changing with respect to y, but there is no y in the function. It's kind of like asking what will happen to x square if y tends to 5? Look at this. What will happen to x square if y changes? Nothing. It will remain as x square. That's it. And I hope you remember how to deal with such limits. We know a fact, when y becomes large, 1 by y becomes very small. So what we do is, we will divide throughout by y. We will divide throughout by y because my intention is to create 1 by y. So y by y, y by y, 1 by y. So we get 1 minus 1 minus 1 by y. Minus, here we get the same function. Okay. And now you apply infinity. So log 1 will be 0, and that is equal to minus log s by s minus 1. Okay, we can apply one more property here. Can you tell me what is log of 1 by a? That is, log 1 minus log a. So minus log a. That means minus log a is log of reciprocal. So that will be log s minus 1 by s. And one very important thing, if you look at many books which comes from very good universities, they will not use log anymore. In old calculus books, they always used log, and the mathematicians will assume, okay, we are learning calculus, so the base is e. But nowadays they don't do that. They will be very specific. And to be honest, integral 1 by x, they will write as ln x itself, because ln x stands for log x to the base e. Anyway, we still follow this notation, but you should always remember this is to the base e. But the proper way of writing is write ln x. So let's move on to the next question. Laplace of cos at minus cos bt, the whole divided by t. Please mark it important. Whenever you have divided by t, we write the Laplace of the numerator. So what is Laplace of cos at minus cos bt? Apply linearity property, and the trick I told you, c means it will start with s by s square plus a square minus s by s square plus b square. Okay, great. Now I am going to write the same thing. Now I don't have to do this much of drama because you already know what I am going to do. The property of dividing by t. Tell me please. I stopped the drama. So now you tell me what to do. Look at the last property here. Integral s to infinity. Remember, this is an improper integral, and you should integrate this part. So if you know the Laplace of this quantity, the Laplace of that quantity divided by t will be integral of that answer. S by s square plus a square minus s by s square plus b square ds is equal to, now let's make it like a proper integral. Whenever you have an improper integral, this is how you have to do. S to y, s by s square plus a square, s by s square plus b square ds. You have to understand one thing. Suppose the derivative of the denominator is in the numerator, then the integral will be ln f, or you can write log f, that's okay, quite okay. So if you have something like x square plus 7, and if the numerator is 2x, and if you perform this integration, it will be log 2x, x square plus 7. Suppose you have tan x in the denominator and the derivative of tan x, x square x in the numerator, then the answer will be log tan x. Okay, remembering this fact, what I do is, okay, the variable of integration is s and the derivative of s square is 2s. So I am going to introduce 2, and I am going to take 1 by 2 outside. I hope you understood that. So in the next step itself, I will get the answer 1 by 2 limit y tends to infinity log or ln s square plus a square minus log s square plus b square. And that will be 1 by 2 limit y tends to infinity. What is log a minus log b? Of course, you have to write limits s to y. Yeah, what is log a minus log b? Log a by b. Within the limits s equal to s to y. Now time to plug in the limits. So that will be 1 by 2 limit y tends to infinity. What we do is we plug in the upper limit. So we get log y square plus a square by y square plus b square minus log the same thing, because if you replace s with s, what will happen? Nothing. So I write the same thing. Now we have to distribute the limits. But I already showed you in the last problem what will happen. So I am not going to do that. I am going to do the trick right now. I am going to divide throughout by y square here. So I get log y square by y square is 1, a square by y square by 1 plus b square by y square minus, if you apply this limit, nothing will happen. So I write the same function. I already explained everything when I did the last question. And this will be, of course, this will be 0, this will be 0, because when y becomes very large, 1 by y, 1 by y square, 1 by y cube, everything becomes very small. And log 1 is 0. And we get the answer minus 1 by 2 log. So this part will be gone. S square plus a square by s square plus b square. And now this minus goes inside and we will get log s square plus b square by s square plus a square, and half will be here. That's it. Now another question of the same type. Evaluate the Laplace of e power at minus cos 6t the whole divided by t. So you know what to do next. You find the Laplace of the numerator, which is 1 by s minus a minus s by s square plus 36. So now you tell me what will be Laplace of the same thing. Look at this, I am writing the same thing, but I am going to divide by t. So what will be the answer? Yeah, we have to integrate from s to infinity this quantity. 1 by s minus a minus s by s square plus 36. And I am going to split this because now we have to integrate, making it a proper integral. First function minus second function. Okay, now you know what to do. The derivative of the denominator is 2s. So I am creating that 2s over here. And this is very easy to integrate, so we can do that directly. So this will be limit y tends to infinity. The first function will be log s minus a. And second one will be minus 1 by 2 log s square plus 36. I hope you remember, if the derivative of the denominator exists in the numerator, then the answer will be log. And this gives me limit y tends to infinity. Do you know what will happen to half log a? This will be log 8 to the power 1 by 2. And that will be log of root under a. So you remember this property. Because log a power b is b log a, or b log a is log a power b. So the first function remains as such. Log s minus a. Minus this half becomes log root under s square plus 36. Of course, we have to write within the limits s to y. We should have done that in the last step itself. And we end up with limit y tends to infinity log s minus a by root under s square plus 36, because log a minus log b. So the usual story, and that will be limit y tends to infinity. Okay, now let's plug in that s equal to y. So we get y minus a by root under y square plus 36 minus, of course we'll take what you call limit etc., and the second one will not be affected. So I'm skipping a lot of step, and I hope you are doing this by yourself. So s minus a by root under s square plus 36 after taking limits. Now look at this, the highest degree is y. So I'm going to divide this throughout by y. So y by y is 1, a by y, and here this 1 by y will go inside as 1 by y square, isn't it? Because 1 by y is actually root under 1 by y square. So divided by root under 1 minus 36 by y square. I'm sorry, 1 plus. Minus the same thing, s minus a by, because this will not be affected by the first one. Anyway, as usual, this became log 1 and 0. We forgot to write log because the whole story depends on log. Okay, anyway, you understood. So the answer will be log, I skipped a lot of steps, you can try it yourself, s square plus 36 by s minus a. Okay, so that's it, my friends. So make sure you practice a lot, and these questions are very important. And in case you don't understand, or if you have any trouble with the steps, please do email me, or you can talk to me directly through my website. Just check out my website www.sjmathtube.com, and if you are getting stuck with some sort of steps, or if you want to make some special video, you can of course contact me through my website. So I'll be back with some more very important problem. So till then, my friends, bye.